This video will present solutions to the VCE 2023 Mathematical Methods Written Examination 2, Section B, Question 3. This question starts off considering the function g of x equals 2 to the power of x plus 5. In Part A, we are asked for the limit of g of x as x tends towards negative infinity. As x tends towards negative infinity, 2 to the x tends towards 0. So g of x tends towards 5. ClassPads also have a limit command which can be used to find such values. This command can be found under Interactive Calculation. The point that x is approaching is negative infinity, with the infinity symbol found on the Math 2 keyboard. As there is only one direction from which one can approach negative infinity, this field can be disregarded. As we thought, the ClassPad confirms that the limit is 5. Now we have g of x in the ClassPad, we can use it to answer parts B and C. For part B, we need the derivative of g of x. Whilst you might know this result already, it can also be found by popping g of x into a new line, swiping and differentiating via interactive calculation. From this result, we can see that k equals log base e, or ln, 2. For part C, part 1, we can take advantage of ClassPad's tan line command, found under interactive calculation line. The tangent we are wanting is at the point where x equals a, where a is entered from the variable keyboard. This gives us an expression for the tangent to g of x at x equals a, which we need to write down starting with y equals. For C part 2, we need to find the value of a for which this tangent passes through the origin. This means that the y-intercept is equal to 0. We can set the y-intercept of our tangent equal to 0 and then solve this equation for a. This gives us a equals 2.618. We can now find the equation of the tangent given this a value. This gives the equation of the tangent through the origin as y equals 4.255x, correct to 3 decimal places. Note, the y-intercept of this tangent must be 0 as it passes through the origin. It is not the value given by the ClassPad of 3 by 10 to the minus 9, a number which is close to 0 and is caused by the rounding within the calculator's numerical calculations. Part D asks us to find the coordinates of the point of inflection of the function h of x equals 2 to the x, take x to the 2. Points of inflection are a new element of the course. If I wanted to find them exactly, I would set the second derivative h double dashed x equal to 0 and solve, but we require an answer to 2 decimal places, so I will use the ClassPad's Graph and Table app. This has the added advantage of showing us the graph of this unfamiliar function. Moving to Graph and Table, enter the function and tap the draw icon, as the default view window will work nicely in this case. From the Analysis menu, choose GSolve and Inflection. This output to 2 decimal places is 2.06, minus 0.07. We can answer part E more easily now that we have a graph of the function in front of us. Asking for the interval for which the function is strictly decreasing is asking for the interval where it is not increasing, i.e. where its derivative is less than or equal to 0. Looking at this graph, this will correspond to the region between the local maxima and the local minima, which is when the graph is going down. The coordinates of the maxima and minima can be found via Analysis GSolve. This gives us an interval between 0.49 and 3.21 inclusive. Part F gives us another chance to use Newton's method to find an approximate solution to an equation. Whilst earlier in the paper I chose to use the Sequence app, this time I'm going to use the Main app to complete my calculations. Before I go though, I'm going to copy my function that I entered as y1. As the formula for Newton's method is xn plus 1 equals xn minus h of xn divided by h dash of xn, I will enter it as such, without the subscripts for x. I can paste in my copied function as the numerator, and for the denominator, I can paste it into the derivative template found on the Math2 keyboard. Giving an initial value of x equals 0 and pressing execute, we get an x1 value of -1 on the natural log of 2. As we need 3 decimal places for this question, I will temporarily set my ClassPad to decimal rather than standard, and then we'll re-execute this calculation. Pressing execute again has the convenient effect of duplicating the last command. This time though, the given x value will not be 0, it will be the previous answer. Pressing execute now will give us x2, and pressing it again will give us x3, meaning that we can fill in the table provided. Once done with the need for multiple decimal outputs, it is best to switch back to the standard setting for the remainder of the exam. Part G asks why the solutions to the expression natural log 2 times 2 to the x minus 2x equals 0 should not be used as x0 in Newton's method for function h. The reason for this is that this expression is the derivative h dashed x, and using solutions to h dashed x equals to 0 as x0 makes x1 undefined. Part H considers the function f of x equals n to the x take x to the n. We are told that there is some value of n for which this function has a stationary point on the x-axis. This means that for some value of n, n to the x minus x to the n equals 0, and simultaneously the derivative of n to the x take x to the n is equal to 0. This first equation means that n to the x equals x to the n, which suggests the solution x equals n. That result, along with the derivative equals 0, can be solved simultaneously to find the value of n. Use the simultaneous equations template from Math 1. Use the variable tab for n, and the derivative template from Math 2. Tapping execute, we get the value n equals e. Note, the CAS is less successful at solving the system of equations if you use the initial equation n to the x minus x to the n equals 0. It seems that the solution by inspection, that x equals n, is needed for the algorithm to be successful.